Hello, how are y'all doing? I'm gonna go ahead and go over problem number two. I don't know why and I've scanned them like 1,000 times, and they're like readable, but they're definitely a little bit weird. So definitely gonna do a lot of drawing this time. But gonna go ahead and go over problem number two. That or I'm paranoid and this looks fine, but looks a little dull to me. But yeah, I was gonna go ahead and go over problem two. And so. Reason being, problem two made the most sense to me, and it seems to me like you can just apply the same like couple steps every single time for these problems. And the only thing that gets crazy is the dot products. So for problem number two, I kind of just started following like this step-by-step process. And oh wait, on this one it's outlined, but I mean it's the same thing for problem three and four, other than the steps getting gnarly. But I rewrote the drawing simpler and added an inertial frame to it. And it's kind of like my first step on, I guess, um, writing the position of each particle R1 and R2 with respect to the pivoting in the ceiling. And so how I went ahead and did that is oh golly, I went ahead and Um, I'm just gonna draw on the PDF because that bothers me. Sorry, I don't have an iPad, y'all. I'm doing this from my computer. But write the position of each particle, R1, R2, and how I kind of broke that into pieces, just rewrite the drawing simpler and add an inertial frame. Dorothy made this like pretty easy for me to see from her perspective and the way that she looked at things by like keeping everything in two direction negative. That would be one question I do have for everybody is like, why can we do that? Because I know Amanda kept it positive, and I don't really understand why one or the other uh, would matter if this thing can move up and down. I'm guessing you just have to be like consistent, but I went ahead and made everything regarding M1 going downward. And so you have like R1 equals negative Z here, where um, I basically just related this using this triangle here to into um, via cosine and cosine because where are we at? Take the L, bring it over to here, be just trig, and toss on the direction vector as we're moving downward. And so that's kind of how I got R1. R2 made more sense to me because it's just a composite of this, where's my eraser at? This N1 vector here and this N2 vector here, which is more clearly drawn here and here. Um, oh, I got colors. Yeah. All right. And so I basically just broke it down in components. Again, keeping this convention here, which again, I saw Amanda did not keep this convention, but she got the same answer as Dorothy's convention and my convention. So I don't really, if somebody has like some thoughts on that, it might just be, you just have to stay consistent. But I went ahead and got basically this this gosh, I'm sorry, y'all. Um R1 vector, R2 vector here, and this R1 vector here. For some reason the scan was having trouble. I scanned this about 200 times and it just kept coming out like this, so I rewrote it here. And that's what I got. This makes sense to me because again, negative directions for the two things pointed downward. Assuming that mass that we described here is kind of moving downward. I guess it could move upward as well, but in the way I observed it, it was moving downward. Or at least that's the direction I put on it. From there, simple taking the derivative of the acceleration. Um, that I feel like makes complete sense to me. And what I liked about this is I understand that we're able to do this because these two different R vectors are not coupled together. From there, and again, that's just broke it down in a step like that. And calculate the displacement vector of each particle. This should say virtual displacement vector of each particle. And in terms of the generalized theta and oh, sorry, it does say virtual displacement. There you go. And theta dot and partial derivative theta. I don't gamma theta, I guess is what you say. So I applied the displacements equation from the lectures. I have conceptualized this as meaning I equals number of bodies, J equals number of generalized coordinates. Went ahead, took the partials, respectively here and there. So we can zoom in. Zooming in helps a ton. Yeah, I really don't know what is up with my phone camera. It's kind of concerning me actually. And so I take these two partials here, went ahead and basically solved for the two gammas that we have for this problem. And the way I've conceptualized this is we have two bodies that are, um, I'm saying a lot. We have two bodies that are on the same generalized coordinates. So that's why we only have 1, 1 here. And that's how I've conceptualized this. Again, if that's wrong, could somebody please comment it? Because I was having a discussion with Linda under another post about that. Um, Again, went ahead, boxed my answers. I thought this was pretty simple, straightforward. This is where things kind of got weird to me, but then Google and the fact I've taken statics 3 times helped. Tension is not an applied force, so that's why I did not put it. I drew them on the force body diagram as everybody else seemed to be drawing them. But I Googled it, and since tension's not applied force and it's equal and opposite in both directions, um, doesn't appear here. Gravity makes sense. Applied force. Another discussion that I'd love somebody to comment on, and sorry I keep bringing up things outside of the problem, was that, and I'm going to go ahead and post my write-up too, so y'all don't have to listen to my voice the entire time. But me and Linda were having a discussion about the ramp on problem number, I think it's 3. So if anybody has any comments as to whether or not because Elizabeth's video made sense because it cancels out the normal force, but then I don't really understand why that wouldn't happen to the block, but then there's no friction on the block, so normal force wouldn't really matter. If anybody has any thoughts on that, feel free to go comment. I'd love to hear about that. But anyway, tension's on an applied force, so go ahead and get rid of that. And just went with, the two applied forces, which are the gravities. And then from there, write the differential equation of motion for the system using I have no idea how to say it, D'Alembert's principle and collect all terms. Um, Went ahead and wrote out the equation. Again, iterating on this, somebody commented on it's wrong. What I do whenever I write these out is they get really long for some not for some reason. I mean, they get long because they're long, but they basically just go ahead and write them out all the way. It makes it easier for me to like visualize the dot product and like just go ahead and cancel things out to zero. I think unluckily nothing cancels out to zero on this one because that's an N2, that's an N2. But okay, so some things will cancel out to zero, but I'm pretty sure I just go ahead and distribute. Yeah. I do it in a ton of steps because otherwise it doesn't make any sense to me. And again, boxed answer on a separate page, just cleanly. Um, can't You can read this, but it's difficult with all the eraser marks. I had been using pen, but I made it through like half my notebook already, so I quit using pen. From there, this device. Oh yeah, so this device performs oscillations with a frequency in Hz. So I went ahead and followed the hint. Basically went ahead, assumed anything close to cosine of 0 would equal 1. Anything sine theta, this should say theta. And then another thing Gary said in the hint was I basically assumed that this would be 0 based on the hint because it's a higher order than just the regular level, not the regular level from the first order. Basically just continued breaking it down. Uh, Algebra. Drew this here this is not me boxing my answer or anything. I just wanted to say that the differential equation in the form of x double dot w n x equals 0. This is just regarding the hint. Just made more sense to me written like this. And another thing I thought was funny is this really reminded me a lot from 502, like what we did with eigenvalues, I think. Yeah, I think it was eigenvalues. Yeah, it was like eigenvalues and differential equations, I'm pretty sure. But yeah, anyway, went ahead and took the square root of that said value, that said coefficient, as the hint stated. I got the same answer as everybody else. Again, I think the only difference between me and some of the other individuals that solved the problem was the naming convention, not the naming convention, the convention of the basically the direction at which I went with these when I was drawing like crazy earlier. A couple of people had these as positives rather than negative. I think as long as you're consistent, you get to the same answer. But those are kind of my thoughts on this problem. I thought this problem was a very solid way in how I will be approaching this kind of problem on the exam by basically just going sectioning it off to see if I can remember off to my relative position, gammas, accelerations, masses. Feel like I'm missing something from the little silly equation up here. Let's go look. Got forces, this, gammas. Yeah, that's how I'm going to approach it. Just get these, start with relative position, then go straight into, well, first thing I'm going to do is number of bodies, generalized number of generalized coordinates, and then go into basically like good golly, I'm trying to remember what I want to call this. Basically, go into like looking at the forces, and then not the forces. Sorry. After I get the number of bodies, generalized coordinates, then I'm going to get the relative position of the R's of the two bodies, or however many bodies there are, and then from there, once you have all of that, you can get the gammas, each and every kind of gamma there is based off of the generalized coordinates, and then you can get the forces, and that's how I'm going to approach this problem. Is basically just break it down into, I guess you would say, these 6 steps. The only step I didn't really think was necessary if the problem's directed only towards, I'm going to butcher it again, the Lambert's principle is this one. But this is still nice to do and like look at and understand. But yeah, if you have any questions about what I said, and I'm sorry I'm a little sleep deprived, I'm doing the best I can over here, feel free to let me know. I'm gonna go ahead and upload a write-up as well for this one. Thank you.